Hello guys, my name is Keshav. Today we are going to discuss a problem RGB construction, which is basically a December cook-off problem. So in this problem what we have to do is we have given R red nodes, G green nodes and B blue nodes, and we need to construct a tree from these nodes basically, and we have given one extra condition basically the simple path between any two blue nodes should contain at least one red node and at least one green node. So we have to tell either this kind of graph this kind of tree is possible or not, or if this tree is possible, then we need to print the tree basically, right? The structure of tree. So okay, let's start. Let's start with what we have given is we are given with R red nodes, B blue nodes, B blue nodes and G green nodes. These three nodes we have, right? Okay. Now and we need to construct a graph. Okay, let's first consider a base case where B is equal to 0. We don't have blue nodes. What can we do? We can construct any random tree. We can connect any R node to zeros, R to R. We can construct any random tree, right? C R, and this will be a valid answer because the given condition is applied on blue nodes, and if we don't have any blue nodes, then definitely we can construct any random tree which have R red node and G green node, and it will be our answer, right? Now let's consider if B is equal to 1, what will happen? Again, we can construct any random tree basically which have one blue nodes and R red nodes and G green nodes. Why? Because there is no path between two blue nodes, then definitely we don't have any conditions. We can construct any random tree and that will be our answer. These are basically two base cases, and if the number of blue nodes will be greater than or equal to 2, now we need to think about it. Now we need to construct a tree which contains B blue nodes, R red nodes, G green nodes, and such that a simple path between any two blue nodes should contain at least one red node and at least one green node, right? Yeah. Now let's say if using B blue nodes, x1 red nodes and x2 green nodes. By using B blue nodes, x1 red node and x2 green node, we are able to construct such tree which will follow basically which is correct according to given condition. Okay, and we are left with this kind of tree basically, right? Let's see, we have created one tree which consists of B blue nodes, x1 red node and x2 green node, and which is basically correct according to the given condition, in such a way that x1 is less than R, less than or equal to R, and x2 is also less than or equal to G. Okay, so what we will do, we are left with some green node and some red node. What can we do? We will add the remaining nodes anyhow randomly to the constructed tree. R, G, O, G, R, right? That will not create any issue, because if there is a path from one blue node to another blue node, we are not adding this green node or this blue node to any in between or somehow. So if we are able to construct a tree with blue nodes, x1 R node and x2 green node, such that x1 is less than or equal to R and x2 is less than or equal to G, we can say we can construct basically the tree which will follow the given condition, and after that the remaining red nodes and remaining we are left with some remaining red node and some green nodes, then we will add these nodes to our constructor tree randomly, and we will reach to our solution. Now the thing is how we will find this optimal number of red nodes and green nodes, right? Yeah. So let's consider the base case. If the number of blue nodes is 2, what will be our optimal tree? We will add one blue nodes. We will add basically 2 blue nodes. Let me add it correctly. This one blue node, this second blue node, and we will add one red node and one green node in between these 2 blue nodes, right? Yeah, this is basically true according to the given condition, because there is on a simple path between any 2 blue nodes there is one red node and one green node, right? Yes. Now if we want to add one more blue nodes, where we are going to add? If we will try to add the blue node to this node, we have to add one green node and one red node, right? Before adding one blue node to this node, right? Similarly, if we are going to add one blue node to this node, we have to add one green node and one red node. One green node and one red node before adding this blue node, right? But if we are gonna to add the new blue node to this red node, let me add one. If we are gonna to add one blue node to this, what we have to do, I have to do is basically I have to add one green node. Why? Because there should be at least one green node, right, in this path. So I have to add one green node, and according to this path, condition is also satisfying on this path as well. Or if I will add the new blue node to this node, I have to add one red node, right? After adding one red node, I can add one blue node. Why? Because there should be at least one red node in this path. In this path, there should be at least one red node. So I have to add one red node, and for this path, I need not to worry because the condition is already satisfying. So you can see the optimal way is to add one more blue nodes. If I consider this basically this tree as a base tree, now in this base tree, if I want to add one more blue node, either I need to add one green node or one red node, right? I can add one green and one red and then one blue, but definitely this is not the optimal solution. Our optimal solution is either one green node and one red, or one red node, right? Let me erase this. Let me erase this one as well. Yeah. Now let's say I have add one blue node to this node and one blue node to this node. Now if I want to add one more blue node, what I will do? I will add just this red node, then I will add one green node and one blue node, right? Because basically this red node or green node is directly connected to one blue node, right? So because of the given condition, we have to add either one red node or one red node before adding one blue node, and other than this node, for all other nodes the condition is already satisfied. So to add blue nodes, either I have to add one green node or one red node. And if I left with now let's say I have completed all the blue nodes. Now I left with let's say X green node and Y red node. What I will do, let me change the pen color. What I will do, I will just randomly add on the last node. What I will do, I will randomly add red node, green node, again red node, again green node, whatever the amount I have left with. Why? So in this way I can construct a given tree. Now let's go through the code. So first of all we have t test cases, so I have taken the t, then RGB, the number of red node, green node and blue nodes, then if b is greater than 1. So basically I am talking about this case, right, this one. If b is greater than 1, and it means b is greater than or equal to 2, right? Yeah. So if I have 0 red nodes, there should be at least one red node but at least one green node. So if number of red nodes is 0, number of green nodes is 0, or basically you can see, if we consider outside of this base tree, for adding one blue nodes, either I need one green node or one red node. So basically we are left with outside of this base tree, we are left with b minus 2 blue nodes. To add b minus 2 blue nodes, I need extra b minus 2 node, either that one of them anyhow, like I need at least b minus 2 nodes, either it is green or red or mixture of green and red, I don't care about that, but there should be at least b minus 2 nodes, right? And for this base tree also I need 2 nodes. So basically the total number of nodes what I require is b. So so basically red plus green must be, the value of red plus green nodes must be at least b, right? So if r plus g is less than b, definitely there will be no answer. So I am just printing -1 and continue, right? If b is less than 2, what does that mean? I need not to worry about any condition, right? So I can just throw any random tree and that will be my answer. So what I am doing is print. Basically print function, what print function is doing, print function is doing nothing, it is just printing this character frequency number of times, right? So just I am printing b number of time, character r number of time, character g number of time, and then what I am doing is there are r plus g plus b minus 1 node, number of nodes, number of edges basically in our tree, and what I am doing is connecting I plus 1 to I plus 2. So basically this will consist of, like, if I give my number to the nodes, like 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, and 4 is connected to 5, and how I'm giving them color, starting with blue. If I have, let's say, one blue, then blue, one blue, then I have, let's say, 2 green, I'm just giving green to them, and for red I'm just giving them red color, right? If b is less than or equal to 1, right? Yeah. Now continue. Now we are left with this main case, b is greater than or equal to 2, and we already considered the case where the tree is not possible, so we are left with only the case where tree is possible, right? So first of all we have constructed this base tree with this basically base tree BRGB. I have constructed BZRB basically. What I have constructed is BZRB. Okay, and then vec of I, basically I have created a vector of pair of int, and here vec of I is basically, let's say vec of I is equal to a of b. So basically what it is basically there is an edge between a and b. Okay, so what I have done is like giving number to them, let's say 1 2 3 4. So there is an edge between 1 to 2, 2 to 3, and 3 to 4. That is what I am doing here. The edge between 1 to 2, 3 comma 2 and 3 comma 4 I am pushing to the vector. Now what I am doing is b minus 2, because I have already used 2 blue nodes, 1 green node and 1 red node. So I have just subtracting 2 from b, 1 from r and 1 from g. Now what is my current is basically the current number of nodes which I am going to add. So I have already added 4 nodes, what I am going to add is 5th node, right? So what I am doing is, while r is greater than 0 and b is greater than 0, what does that mean? I have red nodes and I have 1 blue nodes. Now if I have 1 red node, 1 blue node, what I will do, I will just add with green node, red node and blue node, right? And what is the number of this node is current. So what I am doing is, in the given string I am adding RB vector में what I am pushing is from 2 to current, there is an edge from 2 to current, and there is an edge from current to, this one is current plus 1 basically, right? So there is an edge from 2 to current and current to current plus 1. So what I am doing is 2 to current and current plus 1 to current, right? Now I am increasing current by 2. Why? Because I have already added 2 nodes, so the new node I will add is, the number of that node will be current plus 2, right? That is why I am increasing the value of current by 2 and subtracting 1 from both blue and red, right? Because I have used one blue node and one red node. Same I am going with doing with green and blue nodes. If I have green nodes and if I have blue nodes, what I will do, I will add these nodes to this, basically one green node and after that one blue node, right? That is why, sorry, let me draw it correctly. Yeah, that is why basically what I am doing is I am pushing adding in string I am adding RGB, in vector I am pushing 3, there is an edge bit from 3 to current and from current to current plus 1, right? Let me remove this, erase this. Okay, now if I left with some green nodes or some red nodes, what I will do, I will just randomly add green node. Now current, what is current? I am going to add this current. Let's say this is my tree as of now, right? And I am left with 2 green nodes. I have left with 2 green nodes. What I am doing, and the node I have left with is just a minute. Yeah, the node I am with current and current. This is basically current, right? What I will do, I will just add in as, I will add G, and I will add a edge between current minus 1 and current. Again I will add increase the value of current by 1 and then current and current minus 1, right? Yeah, so what I am doing is S plus C vector dot push back current minus 1 and current, and increasing the value of current by 1. Similarly doing for if I have left with some red nodes, what I am doing is while R minus minus S plus C equal to R, and in vector I am pushing current minus 1 current, increasing the value of current by 1, and at the end I am just printing the S and then printing the vector. Okay, that's it. I hope you liked it. Thank you.